Yo, what's up, everyone? If you know me, then you know what. If you were new here, and I guess so, let me introduce myself. I'm Adam, a 15 years old high school student who's trying to rebuild the wheel by making his own network security framework. And now let's get into our main topic. As you know, the first video was mostly an introduction for the tools inside the LightScan toolkit, but today's video is kinda different. You will ask why, and that's because just we are not gonna just read my cute little documentation as the last video, but we are gonna put our hands on real testing, and to be 100% ethical, we are gonna use the scanme.nmap.org website as an example to test our theories. And the best thing to start with, I guess, is LightScan. Now things can get a bit confusing, but don't worry, mate. I got you. So, when I say light scan with the hyphen separating the light from the S with capital S, then I'm talking about the whole toolkit. But when I say just light scan without a hyphen, then I'm talking about the core scanner, which is a tool inside the main toolkit. So I hope things now gets clear. So we are now gonna put our hands on experience. So I have some things I want to test too, so we can get our hands on experience. Let me make the camera goes into my desktop. Now things are clear. So I have some things to test. As you first need to set up your environment. For me, I'm using Windows, so of course you need to install the install the repo. Sorry for that. And then install the npcap library. Then, set up the virtual environment, activate it, and install all the requirements that are used by our tool. So, for example, let's use our. I will get it bigger a bit so we can see, or we can do it full screen. So now, if you want to see all the options in the main scanner, we can use the command light scan or Python. Sorry, you can do Python light scan py hyphen h. You need, of course, to be one from the administrator or have administration right to run the tool, because it uses Scapy, the library, which used row packets manipulation. So you need to have root in Mac OS, Unix, BSD, and Linux systems, and administration right or whatever can make you run a raw packet. As we see here, we have all the options that we can use, like slash help to show the help message, to specific the target, to read targets from a file, and a lot of options. Now in this video we are going to see just the main scan types. Like we have more than 12 scan type, I guess, like TCP connect, SYN, half open, UDP, null, FNAC, XMAX, as I introduced in the first video. So let's try a basic TCP connect scan. We need to specify our target, so we are going to say scan me.nmap.org. We can do /-f, so we can tell LightScan to scan the 100 top ports, and st, so we can specify our scan type, and we are going to use TCP for a TCP three-ways handshake connect. Let's run. This version is still under development, so you will probably, if you will run the latest version and the one and use it in the repo, you will find 1.1.7. So as we see here, we have the open ports, The scan may use the HTTP protocol. It doesn't use the HTTPS. So we can see here filtered ports and the basic firewall analysis. As we see, most ports here are closed, so maybe there is no firewall is running because we are using TCP three-way handshake, which is more clear way. But we can use other scanning techniques to see the reality. Like we can use the SYN, have open scan. Maybe we can get another response from the target, who knows. Same, but to map firewalls directly, in the toolkit we have a proprietary scanning type with firewall defense detection, FDD. You are gonna tell me what is FDD and what that shit is. So if you go through my documentation, the last part of the documentation, you will see a place where I'm talking about the FDD scan. FDD scan is our proprietary scanning technique developed exclusively for us. It sends a TCP packet with the urgent flag set. Plus, the urgent pointer is not set in this packet, so put that in mind. There, as we can see here, the urgent flag is rarely used in legit traffic, making it an excellent probe for firewall detection by analyzing the response. Like we can see, if the response is a reset packet or reset acknowledge flag, then that port is undefended. What that means is there is no firewall filtering our traffic. If we got no response, let's consider that a packet dropping from an active firewall, so it flagged that port as a defended port. And if we get an ICMP type 3 and with one of these codes, then like sorry for the pause. So as I was saying before, when we have an ICMP type 3 with one of the codes, let's scan, detect, and put that packet and put that port as a defended port, because ICMP errors is mostly unknown with all the firewalls, so it's an obvious thing, and we can use it to test our theory. So you can copy paste this command like scan with the target, and you can specify the FDD scan. We should say our response here. As we can see, we have 100 defended ports, so it's kinda obvious because scanme is under is a subnet for the nmap.org, and to verify that it's working, we can use it on the main nmap.org, and let's test our theory. Same thing. So FDD is used to map firewalls and detect ports that have a firewall actively filtering. So this is the main use. It's mostly like the ACK-scan, but a little bit different. Another scanning technique that the LightScan core scanner have is the UDP port scanning. So you can just type -sc UDP, then you can run an UDP scan. Let us see the response. UDP scan is mostly unreliable with SCAPI, but it mostly get the job done. As we can see here, most ports are open filtered and some are closed, so UDP is not that reliable, but I will try to make it work more efficient in the next updates. Another thing we can do is the FinScan. You know, FinScan is where we use the fin flag in the TCP package without any another flag set. So we can run it like that and see the response. Well, expected, because we have already detected with the FDD that there is a firewall filtering, and FinScan just make us know that it's real. Now, if you want to save our scanning result, how we can do that? It's basically easy, but you'll need a workaround. So we are gonna put our command inside quotes. This time I will scan my own machine. And we are going to use the LightSave utility. LightSave make you or give you the ability to save light scan core scan results in a lot of formats. So we need to specify /c to specify the command we want to run, and /s to specify the saving format we want to save. So I can use txt, for example, to see if it's working or not, like here. We can do the command dir in Windows or ls in other desks, and we can see light scan output. We can even see it in real. So I can open my folder and search for it, and here it is, our output. Simple and nice. And you can save in other formats, for example like HTML, so you can get a web page. Oh, sorry. Oh, we find an error. Fine, looks good. HTML, let's try that again. What is the thing with that? Let me see. Oh, maybe HTML is not run. I'll try to figure it out right now. Give me a bit. We are back, and after some troubleshooting in the code of LightSave, I find the error. So you can now run with /f or -s HTML. So you can get an HTML visual report, as we can see here. We can go to the file path, and we are gonna say so. Click on it, and here it is. We have an interactive HTML file, target, scan type, duration, open ports if you, and row scan output. It's a little bit basic, but it covers what you need in most situations. Another saving format we can use is XML, and XML is great for automation, so you can use it to automate things, and I have even an idea to make a compatible version with tools like OpenVAS, so you can run it with them. We can open our XML to see the structure, and you can see the raw output is not pretty fine, but sometimes it's useful. So here is it, the XML. You can close the browser, And the last saving format we are going to use or to see is YAML. YAML is still a new saving format I added in the last update, and it can be useful for some people. We can open it with Notepad++ and see raw outputs here, summary, metadata, and in usual, all the saving formats are useful for automation and to save. We have even PDF, but you can explore that on your own. The last thing I want now to show is LightSniff. LightSniff is the sniffing utility, and it's the most favorite one in my opinion, to be honest. This one is 1.0.2. It's gonna be in the next update. You know, I add an ASCII banner created by this person. If you run it with no flag, you can see all the available interfaces. So we can maybe sniff on the Wi-Fi interface using the -i flag to specify the interface and count to 0 so you can sniff infinitely, and verbose output so you can see additional data. And let's run it by that, and let's see. It can detect TLS, UDP graphic, TCP, UDP, TLS. Let us see. Waiting for, like we can see here, we have ARP, DNS, TLS with codes. I even saw ICMP there. We have a lot of connection here. We can like use Control C so we can stop. We have 2000 packets. We can see like here we can see each row, HTTP, and with the response and size. I have even we have quick protocol used for HTTP3 traffic. It's still how I can say it, not completed, but it runs well, to be honest. It detects other protocol like CSTP, IGMP, and a lot of other protocols I have added recently. So if we want to see an ICMP packet, I guess I will run it again, but I'll run with the I'll run it with the ping, for example, page 8. Here we can see our ICMP packets. Here we can see raw UDP. Here we can see communication between my device on port 443, which is used with UDP for quick communication. So this is all. Plus, when you run /v, you can see the types. So you can see if it's an IPv4, VLAN, or an R packet, you know. And in verbose mode, you can see this additional data. Like for quick packets, you can see show if it's a long or short, pen length, pin, K, size, and here for quick, same thing. For TCP, you can see the flag user. For TLS, you can see the version number and the size, and some additional data. And here with ARP, you can see the request, And even here with ICMP, you can see the type and the code of the packet. And Lightning is, I usually use it when I'm trying to see if a package is sent with other tools in the toolkit like Lightlib. It's pretty useful, but you can't compare it to Wireshark, to be honest. But it's done the work. So that is our video. I hope you enjoy it and get some information about the tools. If you need additional data, you can go to our Discord channel. I have the link in my YouTube channel description so you can join. And thanks for watching and see you in another video.